Hey guys, welcome back to my channel. Hope you are doing extremely well and welcome to yet another lecture of linked list series. So it is a question number 5, practice question number 5. The whole linked list series has been already uploaded on the YouTube. So if you want to help yourself, please do. The link is in the present in the description. Surely you will not regret watching the whole playlist. You will actually master the linked list series, right? Now, the problem for the day is convert sorted list to binary search tree. So you have been given a sorted linked list as an input, and you have to convert this linked list into a binary tree. As you can see, 0, minus 3, minus 10. As I'm going left, the values are decreasing. As I'm going right, the values are increasing. So it is a BST, right? You have to convert this linked list into this BST. Now, few points to remember. First point, the linked list given to us is sorted. And the second point, the tree which I want from you should actually be height balanced. Now, what do I mean by height balanced? That for any node in the tree, height of left subtree minus height of right subtree, the absolute value of this should not be greater than 1. So if you check for minus 10, left and right both are 0, so it is 0 minus 0, that is 0. For the left it is 1, for right it is 0. 1 minus 0 is 1. 1 2 1 2 0. For 9 it is 1 only, and for 5 it is 0. So you can see for any node the difference is not going above 1, so that means the tree given to us is actually height balanced. The tree which is written in the green is actually height balanced, right? Why is this property important for this question? Why is this constraint important for this question? So you can see that if I remove this condition, then you can actually make this linked list into a BST without any difficulty, right? You can just do that minus 10, the right part is minus 3, the right part is 0, the right part is 5, the right part is 9. And now you can see that all this is also a BST. This is not height balance, but this is a VST also, right? So the difficulty of problem is decreased when we remove the height balance property, right? Now, how will you approach this problem? So for the height balance tree, my observations say that the root will always gonna be the middle node. Root is always gonna be the middle node. That is, if I don't try to look it as a linked list, if I try to look at it as a vector, so minus 10, minus 3, 0, 5, 9. This is a vector given to me, suppose. Forget about the linked list for 1 minute, right? If I want to make a height balance tree, it is for sure that I will try to use this as my root value, because this is in the middle. I know that these two will lie on the left, these two will lie on the right, so it is very much probable that if I try to make a BST out of this as this element as root, then it is going to be height balanced. So what will I do? I will say place 0 here, place 0 here. Now, because minus 10 and minus 3 are less than 0, that is the left part is less than 0, it will come in the left subtree. So minus 10 minus 3 will come here, and 5 and 9, 5 comma 9 is gonna come here. 5 comma 9 is gonna come here. From minus 10 and minus 3, what will I do? I can either put a minus 3 here, I can either put a minus 10 here, anything, right? For this, what did we do? We actually did something like this. So my indexes are 0, 1, 2, 3, 4. For finding this mid, what did I do? I said 0 plus 4 by 2 is equals to 2, right? For this minus and minus, see what are the indexes? It is 0, 1. I will do the same approach. 0 plus 1 by 2 is gonna give me 0. Integer division, right? So what I will do, I will place minus 10 here. I will place minus 10. Now minus 10 is actually this. Only one element left here, minus 3. So what will happen? Minus 3 is going to come at right, because minus 3 is greater than minus 10. So minus 3 is going to come at right. Right. Now for 5 and 9, again 3 plus 4 by 2 is going to give me 3. So I will place 5 here. Right. And 9 is greater, so 9 I will place here. Now the tree, these two trees are actually different, but these two are valid. These both are valid. Why? Because this is also a BST. This is also height balanced. So both the properties are getting cared of, and the question wants you to give a valid tree. It doesn't matter that the tree should match the example output only, right? It should be a balanced tree only, right? How will you solve the problem? Now you will solve the problem the same way I did this array. What did I do? I did something like this. For the first node, that is for the root node, my range was 0 to n minus 1, right? What did I do? My first step was to calculate mid. So I said mid, let us say this is my low value, this is my high value. Mid equals to low plus high by 2, right? Then I created a node for that. That is root equals to new node, new tree node to be specific, new tree node of the value mid, of the value mid. That is, suppose this is my array, the name of the array is ARR. So ARR mid, right? Now root left was constructed from the part from 0 to mid minus 1. That is, root left is gonna be, I suppose this is the function f. If this is the function f, which is taking my low, my high, and my ARR, what will I do? My root left is gonna be my function. The function will return low is gonna be my similar low, but the high is gonna be my mid minus one. Why? Because this is my mid, and left part is gonna contain in mid minus one. Send the array also, and similarly root right is gonna be f. Now from mid plus one up till high. You can see from mid plus 1 up till high. This was my high, right? From high up till, from the array, right? From the array. Constructed the root node, constructed the left subtree, consider right subtree, and return root. Return root. Return root. And if you are not able to solve this question in the one go, no problem. This is a difficult question to see, but after seeing the approach, it becomes really easy to understand, right? You should remember till the end of the live now. Okay, so what did we do? We found the mid value. Why mid value? Because we wanted the height balance property to be followed. Then we made a root node. Then we constructed a left subtree. Then we constructed right subtree. You can interchange them. These two are interchangeable, right? Now, after that, we just return the root. We just return the root. Now, when will these steps occur? For every low and high. What is the constraint on low and high for these steps to occur? It is for sure like something like this is happening, right? So my nodes are minus 10, minus 3, 0, 5, 9, right? The index is 0, 1, 2, 3, 4. When I will call this function, what will happen? My first call is made from 0 to 4. My first call is made from minus 10 to 9. Mid is calculated as 2. Mid is calculated as 2. So my two calls are made something like this. 0, that is this low, with 2 minus 1, that is 1. And second call is 3 up till the high, that is 4. For 0 comma 1, the mid is gonna be 0. Mid is gonna be 0. But again, two calls will be made. What are these calls? So my low is gonna be low, but my high is gonna be mid minus 1, that is minus 1. And for the second part of it, my high is gonna be 1, and my low is gonna be mid plus 1, that is 0 plus 1, 1, and my high is gonna be 1. Correct? And for 3 comma 4, my mid is gonna be 3, and the two recursion calls will be uh, from low, that is 3, to 3 minus 1, that is 2, and my low is going to be now mid plus 1, that is 4, up till 4. Now if you see these two conditions, 3 comma 2, that is my low is actually greater than high, and similarly here my low is actually greater than high. Is it possible for me to find a node? If my low has gone greater than high, my mid is also going to be greater than, like, it is possible. Is it possible, right? What is happening is 0 comma minus 1. Is this index possible to get? Am I able to get this index from here? 3 comma 2, what is the mid? So 3 plus 2 by 2 is going to be my 2, and you can see that 2 node has already been made. So my condition is that if my low is less than equals to high, only then proceed with these steps. So what will happen when my low is greater than high? So when your low is greater than high, simply return null. This is your base case. If your low is greater than high, return null, because that is not a valid node to make. That is not a valid node to add to the tree. That's all, right? That's all. Now, this was for the array. You did these steps for the array, and as I said in the playlist many times, that if you're trying to do something on the array and it is working, then the same approach can be made to the linked list. Only the time complexity can occur, like increase or decrease, right? Now, I have got the approach. What do I need? I need the mid value. I need the mid value, and the whole steps are going to be same, right? All steps are going to be same. That is, if I write this as a linked list, that is minus 10 connected to minus 3, connected to 0, connected to 5, connected to 9, right? This is my array. This is my array. This is my linked list. Same, right? The format is same, different, but the values are same. Now, I want the mid value, that is, I want the 0 value. So if I try to index it somehow, 0, 1, 2, 3, 4, can I index it? Like each node carries a particular value. Each node is actually mapped to a value which is its index. You can see map. My clear inclusion to you is use a map. Use a map. That is, when the starting of the problem, what do? You keep a temp here and you keep a cur equals to 0, right? keep traversing and do something like this. MP of temp, MP of cur, that is for this index, my list node is temp, and then move, that is temp comes here, that is 0 will map -10, 1 will map -3, 2 will map 0, 3 will map 5, and 4 will map 9. In this case, you will have got a map. You can use another map. You got the map, you got the map. Now for this map, what you can do, instead of getting ARR mid, you can just say MP of mid, and all the things will remain same. Like MP of mid value you will have to use, right? Because to make a node, you need a value, not the whole list node, right? That is all you have to do. That is all you have to do, changing this ARR of mid to MP of mid value. And your answer will work fine for the linked list as well. Now it is time for you to see the code. If you have any doubts in the approach, please feel free to DM me, or you can mention your doubts in the comment section. I will surely get back to you in no time. Okay, let us see the code now. So here is the coding section. But before starting to write the code, I would like to request you to please subscribe to my channel if you're liking the video, because it really motivates me, right? So my first case is the base case of all the linked list problem. If my head equals to null, return head. Return head. I don't want to do anything with it, right? Now what do you say? If it is not null, then firstly create a global variable of map. So unordered. You can create it inside the function send by reference also, but I'm taking as global unordered map of int, that is to index to list node star, and name it as MP. Now what will you do? You will say list node star temp equals to head and int cur equals to 0. That is the index. Now while my temp is not null, what will you do? You will say MP of cur equals to temp. After that, temp will move forward, that is temp equals to temp next. And similarly, cur plus plus for the next index. After that, just say return solve. Now, cur will contain the length. You can see that cur is actually containing the length of the linked list, right? So you want the 0 to n minus 1 node, right? So send your 0 to n minus 1 is something like this. Send your low as 0 and your high as n minus 1. The 0 high as n minus 1, that is cur minus 1, sorry, right? Length minus 1. Now implement the solve function. So int solve, not int, it is actually tree node star, because we are running a tree node star solve, which is actually taking my low and high only. So int low and int high. What will you do? If my low is somehow greater than high, in that case simply return null, because you cannot process it further. So return null. Otherwise, find the mid. So int mid is gonna be my low plus high by 2. So not if, sorry, you will make a node, that is tree node, let us name this node as root only, is equals to new value, new tree node of MP of mid value. I want the value to make a new node. Now root left is gonna be the solve function. What is the low? My low is gonna be low, but my high is gonna be mid minus 1. And similarly, root right is gonna be my solve function from mid plus 1 up till high. And now return the root, right? Because you process the left subtree, you process the right subtree, you can simply return the root now. Let us try to compile and run it. Hope it will work fine, should not give any error. Oh, there is an error. Okay, if head equals to null, return head. Oh, you have to return null, because head is of list node type, right? I will have to return null, because null can be of tree node star also, right? Let us try to compile and run it now. And it is running fine for the sample test cases. Let us try it for the hidden test cases as well. In the meantime, do consider subscribing, and you can see it is getting accepted. So thank you for watching. Have a nice day. Make sure to subscribe my channel and like the video, and we will meet in the next video. Thank you. Have a nice day.